Okay, thank you very much. Thank you everyone for coming. I think some of you may have seen my previous talks and will have some familiarity with what I'm talking about. Others won't, and so I'll try to straddle the line between not boring the first group and not confusing the second group. We'll see how I do. In 2026, a handful of companies, a handful of large, primarily American companies, control the internet. We can all name these companies. This contradicts the original design goal of the internet back in the 1970s, which was to create a highly survivable, decentralized communication network. The root cause, in my opinion, of this centralization that's occurred over the past 30 years started in the mid-90s as the internet entered the mainstream, and particularly with the World Wide Web. The World Wide Web is what's called a client-server architecture, and with the advent of the World Wide Web, the client-server architecture really came to dominate the internet. It didn't have to be that way. There were other protocols, for example, some of you may be old enough to remember Usenet, which was actually decentralized. But the World Wide Web really won that competition, and with it came the client-server architecture. And my contention is that the client-server architecture, by its nature, encourages and really requires the increasing centralization of the web. Consequence of this centralization is that governments now compete over who gets to censor the internet. We've all witnessed, particularly over the past 10 years, the growing censorship of the internet, both by governments and by corporations, sometimes acting under duress from governments. The goal of Freenet is to solve this problem, restoring the original promise of the internet as a decentralized and uncensorable communication medium. And my hope is, by the end of this talk, I'll have persuaded you that that's exactly what we've done. So what is Freenet at a very high level? Where does it fit in? Freenet is designed to be a drop-in replacement for the World Wide Web. The traditional web, you've got the user. They use a browser, which is essentially a platform for a user interface that runs on their computer. And it uses protocols, mostly HTTP and WebSocket, to communicate over the internet with web servers, which sit in a data center, which is typically controlled by one of the 5 companies I previously mentioned. Within the data center, you've got web servers that are kind of the front end, and then behind those you have databases, publish, subscribe servers, and other things. But all of these things and all of your data sit in these data centers where they are controlled by one of these companies. Freenet takes a different approach. One part of it is the same, though, fortunately. You use a web browser, you interact with Freenet through your web browser, and the web browser interacts with Freenet through HTTP and the HTTP and WebSocket protocol. So far, it's the same. However, instead of using those protocols to talk to web servers sitting in a data center you don't control, they talk to a Freenet peer that is running on your computer, and that Freenet peer is part of a global, decentralized peer-to-peer network. Critically, private data in Freenet stays on hardware that you control. This is one of the kind of fundamental principles that Freenet operates by. The whole, the way that data is handled on the internet today is really just it's a car crash. And this is evidenced by the fact, I think just last week, I got yet another letter saying, oh, we're so sorry, but some company I've never heard of got hacked and leaked your private data. And by the way, here's a largely useless service that will monitor your credit rating as a not very useful compensation for this. And this, I don't know about you guys, but this happens to me maybe 5 or 6 times a year. And this is a symptom of the fact that none of us actually control our own data. We're all expected to just let these corporations handle our data, and they are not very good at it. And in some cases, they share it deliberately, for example, for targeted advertising and that type of thing. So what is Freenet architecturally? Freenet is a global key value store. Key value stores, you see them in computer science all the time. They maybe have different names depending on the programming language. If you use Python, you might call it a dictionary, which is kind of an older term for it. In most programming languages these days, for example, Rust, it's called a hash map. This is where you've got a key, you give it to the data structure, and the data structure will give you value associated with that key. This is also what a file system does in essence. The first really innovative thing that Freenet does differently is that the key in the key value store is actually WebAssembly code, and called a contract. And contracts are identified by a Blake3 hash of that WebAssembly code. So the identity of a contract is tied to the actual code which defines the contract. And the role of the contract is to do several things that relate to the data, to the value that's associated with that key. Firstly, it says, given a particular value, is it valid under this key? So a very simple example of that would be saying, is the data digitally signed by a particular private key associated with a particular public key? But it can be a lot more sophisticated than that. The contract is also responsible for specifying how the data can be modified, who can modify it, under what circumstances. Again, a simple example of that might be to say, well, the modification must be digitally signed with a particular private key associated with a public key. And then lastly, the contract is responsible for saying, how can the data be efficiently synchronized across the network? And I'll go into more depth on that a little later in the talk. The 3 key building blocks within Freenet are the contracts, which I just mentioned, delegates, which are designed to solve this data problem. A delegate is code. It's a little bit like local storage in a web browser, but much more powerful. A delegate is code that stores private data on your computer and governs who can access that private data. So with a browser's local storage, if you wanted to access, let's say, a private key, you would the web page would retrieve the private key from the browser's local storage, use it to sign something. Whereas with delegates, we don't want to be moving this private data around, because every time you move the data, that's risky. So you will ask the delegate, hey, delegate, please sign this data. And one of the key ideas with delegates is that whenever you communicate with the delegate knows who it's communicating with. So if for example, what's communicating with the delegate is a user interface, some WebAssembly code running in a web browser, then the delegate knows what the WebAssembly code is that it's talking to. And so it might say, oh, I recognize you, I trust you, therefore I'll sign this for you, or it might not. So a global key value store. How do you have a completely decentralized global key value store that scales? And the key idea that Freenet relies on here is called small world routing. you're probably all familiar with small world networks to some degree because human networks tend to form small world networks. The origin of small world networks goes back to the 1960s. A social scientist called Stanley Milgram did an experiment where he went to Kansas and he created a bunch of letters, all of which had the name and address of people in Boston, Massachusetts written on them. And he gave these letters to people in Kansas and told them, you've got to get this letter to this person who you don't know, but you can only do it by sending it to someone that you know personally. They have to send it to someone that they know personally, and so on. And so he released a few hundred of these letters, and he discovered, to his amazement, that not all of the letters made it, but of the letters that made it to the destination, they went through an average of 6 people. And this is the origin of the term 6 degrees of separation, which I'm sure you've all heard of. And so in a country of over 300 million people, you can get from any one person to any other person going through personal relationships in just 6 steps. And the reason for this is that human relationships form small world networks. If human relationships were just formed at random, where each person knows 20 other people randomly selected from the population, this would not work. But human relationships have this property where the closer to someone you are geographically, the more likely it is that you will know them. You're much more likely to know your next door neighbor than you are to know a random person in China, for example. And the way Freenet works is peers in the network self-organize into a small world network. The Freenet network is organized as a ring where every peer in the network is assigned a number between 0 and 1, where 0 and 1 are effectively the same number like a clock. And also contracts in the Freenet network are assigned a position on that same ring. And so when I say that 2 peers are close to each other in the Freenet network, that doesn't mean that they're geographically close. It means that they are close on this conceptual ring. And in fact, the location of a peer on this ring is determined by a hash of the peer's IP address. So, and there are kind of reasons for that I'll go into, but because it's a hash, it's effectively randomized. So just because 2 peers have similar IP addresses doesn't mean that they'll be close together on this network. And the really interesting thing about small world networks is that they scale really well. In fact, small world networks scale logarithmically in the size of the network, which is the same kind of scalability characteristic that, for example, a red-black tree has, or any of these key value data structures that we're all familiar with. So it scales potentially up to billions of peers, no problem. So one of the difficult problems in any decentralized network is how do you ensure that data is consistent without a central authority? If you've got a central authority, it's fairly straightforward. The central authority can just say, this is the data. If you disagree, I'm right and you're wrong. But in a decentralized network, you can't have that. So, and this is an extremely hard problem. Bitcoin, in effect, spends $7 to $8 billion per year in electricity solving a version of this problem. Our approach is different. Our approach with Freenet is that the state, which is the value that's associated with a key, the data in the network, one of the things that a contract does is, for its state, it needs to specify a way that any 2 different states can be merged together. and merged particularly in a way such that it doesn't matter what order you merge the states in, you will always end up with the same result. So this is, I hate using this term because it kind of confuses things, but I'll say it anyway. Mathematically, this is called a commutative monoid. But don't worry about that. You don't need to know anything about that to understand this. It's actually a relatively simple concept. And so because states can always be merged, you get this thing called eventual consistency, which means that given enough time, assuming that the network isn't significantly broken, all of the peers that are hosting a particular contract will eventually converge to the same contract state. And then the question is, well, how do you make sure that the state can always be merged? And that's up to the author of the contract. From Freenet's perspective, state is just an arbitrary block of bytes. So Freenet doesn't even dictate what serialization format you could use. You could use JSON, you could use bin code, you could use whatever you want. But it's defined by the contract. So let's say you've got a contract in the network and it's got some state associated with it. And let's say the state is a couple of megabytes. Maybe the state is a single page app, for example, like a group chat app like River, which I'll talk about a little bit later on. That's maybe 3 megabytes of WebAssembly and HTML and images and stuff like that. Let's say you've got 2 peers in the network and they've each got a different version of that state. And the question is, how do those peers synchronize that state efficiently? So in this diagram, you can see here that the state is just represented by images. You've got 2 peers, and you'll see that here their state has diverged. They've got each is storing different things. And so the first thing that you do is each peer generates a summary of its state. And just like everything else in Freenet, Freenet doesn't care what the summary is. The summary is, as far as Freenet's concerned, the summary is just arbitrary bytes. What those bytes mean is entirely defined by the author of the contract. In this case, the summary is just a textual description of the image, but it can really be anything. So each peer generates a summary. Those peers exchange their summaries, and then using the other peer's summary, it says, what data do I have that the other peer is missing? It identifies that data, and it puts that data in what's called a delta. You could think of this as being similar to a diff in if you're dealing with GitHub or source code. The peers then exchange that data, and now both peers are synchronized. They have the same state. And the beauty of this approach is that they were able to do this by transferring the minimum amount of data. So provided that the contract is intelligently implemented, this provides a mechanism that peers can very efficiently synchronize their state to ensure that all of their state is consistent. Okay, so one of the goals of Freenet, I mentioned that Freenet is a key value store. Freenet is an observable key value store. And what that means is if you're interested in the state of a particular contract, you can subscribe to that state and you can be notified immediately if that state changes. So this is functionality that some databases can kind of do for you. Postgres has a update mechanism. Some of the more advanced databases can notify you when data changes, but a lot of databases can't, and those that do, you can run into a lot of efficiency problems and scalability problems if you use this functionality. But Freenet is designed to do this natively. And the way that Freenet notifies people immediately when state changes is, let's say if I'm interested in a particular contract state, I will send a subscription request out into the network. And specifically, I'll say, I will send that subscription request to the peer that my peer is connected to that is closest to the contract I'm trying to subscribe to. Now, the immediate peer that I send it to probably won't have it, but it will then do the same thing, and the next peer will do the same thing. And because peers in Freenet will tend to host contracts that have locations that are close to them on the ring, very quickly the subscription request will reach a peer that is hosting that contract, and then that state will be returned back along this path to the peer that initiated the request, and that connection will then remain live. All of the peers in that chain that forwarded the subscribe request will then temporarily host that contract. And hosting a contract means that if two peers are hosting a contract and they have a direct connection, and the state of that contract changes on one of those peers, the other peer will be notified immediately. So here you have a chain of peers, all of which are hosting the contract. So if the state of that contract changes, it will then propagate along that subscription tree. And I will show you what that looks like. Okay. I showed this to a friend of mine. He said it kind of reminded him of an ayahuasca experience he had one time. So hopefully nobody here will be affected. But here you can see a subscription tree. The peer at the top is the peer that is presumably closest to the contract that's been subscribed to. You can see in the tree that updates here, they're just occurring at random. So an update can start at any point in the tree. And because these peers are connected directly to each other, any update will propagate like a virus through the tree. And one of the really neat things about it, you will see that even though the updates are constantly happening, and actually an earlier version of this slide, they were happening a lot more frequently, and it kind of made people feel ill, so I slowed it down. But the beauty of this is that updates can occur all over this subscription tree, and the tree will always converge to what should be the latest version of the state. So if you're building a system on top of Freenet, how does that compare to building on the traditional web? Well, firstly, there's a lot less infrastructure that you need to deal with. There's no cloud infrastructure, their DNS, databases, all of this stuff is taken care of by Freenet itself. So Freenet really is kind of a drop-in replacement for all of this infrastructure. Going out and getting your SSL certificates is irrelevant with Freenet, because with Freenet, everything that needs to be is digitally signed. Contracts are identified by hash of the contract code. So in effect, just by accessing a contract, you know what the contract does, because you can see its code. If you could either decompile it or find the source code for it. And then of course, delegates also take care of like what 1Password or LastPass or whichever password manager hasn't been hacked yet. It seems like it's just a matter of time. Yeah, so, and it also means you don't have to pay anyone to host. It's all just hosted in the network. Freenet prioritizes based on popularity. So if you put data in the network but nobody cares about it, eventually it'll fall out of the network. If a lot of people are accessing your data, if a lot of people are subscribing to your contracts, then it will be widely cached within the network, widely hosted within the network, and very, very unlikely to fall out of it. So, yeah, so the key thing, I think, with this talk, and the difference between this talk and previous talks I've given here, is that Freenet is now live. It's up and running, and I may regret this, but I will try to go to a live version of the dashboard here. Yeah, so this is a real-time visualization of the Freenet network as it is at the moment. It's still pretty small, it's just 19 peers, but like I said, the small world network that this is based on can scale up to billions of peers. You can see the ring, all of the peers are arranged on a ring, and you can see how some of the peers are connected. You can actually, is this working? No, it's not, okay. You can see how some of the peers are connected, and in fact, peers that are close together are much more likely to be connected than peers which are distant, although because the network is still relatively small, most peers are connected to most other peers at the moment. Yeah, and so you can kind of see the small world topology, and I don't know if if you see the timeline at the bottom, you can see messages being sent. Most of the pink ones are subscribe requests, which we talked about, and then various other types of messages. Now, the challenge here is going to be getting back to my slideshow. Let's see if we can do it. It's always a risk to use Linux with these things. Let's see if I close this. We get back, okay. And, okay, phew. That was the highest risk moment of the talk, and we survived it. Yeah, so this dashboard, you're actually welcome to visit it right now. It doesn't have the friendliest URL because we don't want it to get posted to Hacker News because it's not designed to handle a vast amount of traffic. But if you want to check it out, the URL is just nova.locut.us, port 3133. And you're welcome to find it. You can play around with it. You can see contracts. You can see events as they occur. There's a timeline. You can scroll around. It kind of went a little bit nuts with the dashboard, but I love dashboards. This is really having built peer-to-peer things for 26 years, this is the dashboard I always dreamed of having, and so it's pretty neat. We have built really a proof of concept application, but it's a fairly full-featured group chat app called River. River is distributed over Freenet. You actually, the user interface for River is downloaded from a contract through your web browser. If you want to try it yourself, you can just go to freenet.org/quickstart. There's some instructions, and in about 2 minutes, you should be up and running with River. But behind the scenes, each room in River is itself a Freenet contract. River uses delegates to store all your private data. So in this case, it's really the private key associated with your identity in River. And it's got reactions. It's got a lot of the functionality that you would hope for in a group chat app. Right now, each room you've got a room creator. They can invite people. Those people can invite other people. And you can ban anyone who you invited or who is kind of downstream from you in the invite chain, which is a simple kind of mechanism to prevent abuse. Will make it more flexible in the future. So if you want to build on Freenet, and I guess I'll use River as an example. So as I said, with room contracts, each chat room on River is itself a contract. The contract consists of a list of users. For each user, it's got a public key, and that public key must be signed by the person who invited them. You've got the user interface that you just saw, and you've got a delegate which stores the user's private key. And let's say if you want to send a message to the River room, what's going on behind the scenes is the user interface is asking the delegate to sign your message, and the delegate verifies that the user interface is what it's supposed to be, and if so, it will sign the message. So what that means is you can visit River in your web browser. You can even change to a different web browser, and if you look at River, you'll see all the same data, and you'll be logged in just the same, because we don't use the web browser's local storage. Instead, we use delegates because they are better. So my degree is in artificial intelligence, and Freenet is not, I would say, directly associated with artificial intelligence, but one of the challenges with Freenet is, okay, so you built a better internet, but we've got all of these services on the internet today. How the hell are you going to replicate them, or enough of them that are useful? And I think there's an interesting convergence that's happened at the moment with the advent of coding agents, where coding agents are just about at the point where you can give it a problem, and with sufficient guidance, it's able to build a solution end to end. And we're very bullish on AI. I know that some people are more skeptical of it. We've had a very good experience with it. And so what we've done, for example, we've created a Claude Code skill that can be used to build decentralized apps on Freenet. And our hope is that this will dramatically increase the speed at which we can get up to feature parity with the internet, because people can use suitably guided coding agents in order to build really whatever they can imagine. I'll be honest that we haven't used a coding agent to build an app from scratch end to end yet, but we're pretty confident that we're pretty close to being able to do that. And so taking the AI conversation a bit further, in many ways, Freenet is like the perfect communication substrate for AI agents. We're, I think, pretty close, and there's already been some stuff even just in recent weeks with AI agents being able to collaborate with each other. In a world where everyone's got their own AI agent, we're going to want these agents to be able to talk to each other, ideally without them conspiring against us. So we kind of want them to be able to talk to each other in a kind of open way. And that communication, that coordination problem between agents, part of the challenge is these agents can't necessarily really trust each other, but what they can trust is Freenet contracts, because contracts in Freenet are able to are defined by the code, and that code is auditable and transparent. And so I contend that if I was an AI agent, I would love there to be something like Freenet, because it will allow me to communicate with other AI agents in a way that where there can be trust, not necessarily in the other agents, but in the communication, because the communication itself is mediated by Freenet contracts. Okay, so yeah, in terms of getting involved, you can run a peer yourself. You go to freenet.org/quickstart. You can be up and running in 2 minutes. It's just very quick. You cut and paste a little bit of code, paste it into a terminal, and it'll install and it'll get running. And then also on that page, it'll allow you to be invited to the river room. So you can really, in 3 minutes or less, you can be up and running with Freenet running on your computer, and you can be asking questions in the river chat room. We also have extensive documentation on our website. There's tutorials, just a huge amount of information, which we try to keep up to date. And as I said with the previous slide, we also have not just a skill for building decentralized apps, we also have skills for working on Freenet itself. And so if you're interested in contributing to Freenet, if you know Rust, you can do it directly. But we've also made it very easy for people to use AI agents. And we use AI agents pretty heavily, although, of course, any code that we commit is reviewed by a human, so it's not like slop. And then so we also have a Matrix channel. You can find a link to that on the page. So with that, I'll open it up to questions.